everyone. I'm Shivansh Singh. I'm a principal solution architect, work for Amazon Web Services, and I'm happy to be here talking about building products from prototyping to production and how you can use agentic IDEs uh, like Kiro for building your applications and pushing it into production. So just a journey how we arrived here. As some of you might already been in the industry, in the software development or somewhere related. And in 2024, if you remember, we started almost with coding assistants, right? You are writing code and you have these assistants that help you probably complete a specific function that you are writing, or it is helping you to finish the classes that you are writing or a partial piece of the code that you're trying to do. And then in 2025, which is kind of the time of agents where you are actually using almost complete end-to-end development using these agents. That's where the era of agent has started. Some of you might have already used that. Some of you have seen this in action where you are actually writing the complete functions and having agents sit right next to you and help you with writing the code. And here in 2026, it's about complete autonomy. Now, when you're talking about agents in 2026, we are talking about not just something that you actually constantly prompting to build products, but you are actually want these agents to be able to take these tasks, run it for hours or even days, and come up with an end-to-end complete product back to you with the exact requirements and the design that you have expect. So we are talking about complete autonomy when it comes to the agentic development of these products. Now, the promise of agentic development is categorized in these three ways. One, we are talking about autonomy, which means agents can take on complete and comprehensive tasks and finish it end to end with full autonomy. You are not asking it to write code. You're not asking or prompting it in between. You are just giving it a specific task or a specific user story that probably you are used to in terms of software development lifecycle. And it is figuring out what is the best design it needs to be. It is looking into your code base. What are some of the patterns that you are actually have used in the past? And it is actually following those guidance while it is developing that. So it's fully autonomous agents that are doing these product development end to end. The second promise is about true collaboration. What that means is, as agent is working on these tasks that you have provided, it is at some point, if it has questions about a design or a decision it needs to make, it can come back to you and ask follow-up questions about a specific requirement that it is not clear or a specific design decision that needs to be made when actually developing those products. So it's a true collaboration between the developers and agents working together to get something done. And the third is a much higher quality. It's not just about being able to write a function or being able to get the output, but being able to heavy lift most of the things all the way from writing the unit test, making sure all the test coverages are done for all the functions and the products. It is not just building features, but also documenting it so that the other developers or even other agents can actually use that documentation to learn about what that particular function or what that particular product is doing. It is optimizing the performance and fixing security vulnerabilities. So it's complete end-to-end 360-degree look at your product, what it is building, and not just writing the feature. Now, with that comes certain challenges. The first challenge is scaling the AI development beyond smaller tasks. So when we say smaller tasks, as I mentioned earlier, we are thinking about how we can actually leverage these agents to scale to build across the entire portfolio of products that you probably have in your organization. So it's not anymore a small unit of tasks that it's able to complete, but how it can actually scale to much complex projects in your organizations, or even when you are building yourself. You have dependencies. You have dependencies to third-party libraries. You have dependencies to some other code bases. So how it can figure out those dependencies and take all of that into consideration when it is building the complex project end to end. The second challenge is the limited control. What that means is how it can use existing tools and collaborate with other agents to build the product end to end. So it's not about just one agent writing the entire feature set. It is how multiple agents can collaborate. One agent might be a security agent who is looking at the security vulnerabilities in the project. Other agent could be an agent who is front-end focused, who is actually identifying the opportunities to build engaged UI. The other agent could be focused on writing the documentation and making sure that test coverage is proper. So how these agents can collaborate with each other while having the control that is needed to be able to perform that task. And then the last challenge is the overall test code quality. It's not anymore whether you are able to write these projects or the products end to end with a specific feature set. It's about how do you have the great quality product when these agents are building these projects. So how do you maintain that quality control becomes increasingly complex and important when you are leaning onto these agents for autonomous development. So the question is, what would a development experience look like if it could take full advantage of working with these AI agents? We have been in this software industry have been used to following software development lifecycle, right? There's a well-defined workflow of building these software products. Now, how that it changes when it comes to agentic AI development. And that's where the spec-driven development works. It's no more vibe coding. It's not like you come to this IDE and you start providing prompts and building products. It's how do we use the software development lifecycle best practices that we have learned over a decade or more and apply those with the agentic AI development to use these same best practices and same learnings while getting the most out of these agentic AI development. So in that spec-driven development, you see here, it's applying the agentic AI development in the entire development lifecycle, not just when you're writing the code. So using the planning and design phase, when you are actually identifying what you want to build, it's about how you can take these agentic AI IDEs and agents to help evolve your user stories. Like starting from a problem statement, right? You have a problem, you are trying to build a product around that. How do you gather the requirements? How can you use agents to actually help you explain and elaborate on those requirements? Then, once you are actually in the design phase, how you can actually use these agents to define and design your product from those requirements, considering all the best practices that we have learned over the years to define those design decisions. Now, once the design has been identified and finalized, then move into the implementation phase. And that's where the agents can really take those requirements and the design that you have put together, working with these agents, and implement it into the feature sets that you are trying to build in the product. And again, taking it from there, iterating it constantly, and writing the test cases, deploying it into production, learning from that, looking into the logs, looking into the metrics, taking that learnings and bringing it back into the software development lifecycle, and constantly improving the quality of your product as well as the learnings that you have while building that. So it's no more about using agents to just write code. It's using the agents in the entire software development lifecycle, all the way from requirements, design, implementation, testing, documentation, and then completing that loop while using these agents. So that's where Kiro comes into play. Kiro is an agentic AI development IDE. It helps you to write code not just using at the time of implementation, but starting it from the requirements all the way to the design and using the agentic IDE in your entire development lifecycle. So what I'm going to do is jump into the, maybe show you, instead of just slides, jump into what Kiro looks like. So here is what the Kiro agentic IDE looks like. On the left-hand side, you see it's your typical IDE where you have your source code, your files. I have a basic primitive construct of all the simple white framework that I have already downloaded here so that we can spend less time building that artifact and focus more into the IDE. On the center, you can see that it's a simple editor like any other IDE. On the right-hand side, I have this chat window, which is where I can actually interact with Kiro. So like you see here, it's a chat box here. I can write, hey, how are you doing? And it's basically going to come back and the response, right? So this is where I interact with the IDE, and I can start interacting with agent to build my project. Some of the other things that you will notice here is in the bottom, you can see I have auto mode enabled, which means fundamentally what it is doing is it's automatically deciding which is the large language model it's going to use for my prompt. So I'm not selecting a specific model. I'm letting Kiro decide which model it wants to use based on my request or my prompts. However, I have option to choose whichever model I want to choose. There are a lot of different models from Anthropic like Claude, Claude Sonnet, Claude Haiku, and also there are open weight models like DeepSeek and Qwen models. So you can choose variety of models, and each model has its own number of tokens that it will be used to build or to build the project. So I'll keep it in auto. In the bottom, you can see that there are it shows you how many credits are left. So I have barely used anything for this particular account I'm using. So you can see I have 500 credits available, and I have only used 0.08 credits. Now, one thing you will also notice here is this little ghost icon. This is a mascot of Kiro. When I click here, the left-hand side is what makes the most interesting about this agentic IDE. On the top, you see the specs. Now, spec is basically the project plan that helps you write these projects in a software development lifecycle, following the software development lifecycle methodology. So I'll show you how actually you can use this when writing your project. So what I'll do is I'll start with a simple product building, right? So in this demo, what I want to do is I have put together this simple high-level flow of an app that I want to build, and this is a interview preparation app, right? What I want to do is I want to build an app that actually helps me prepare for interview. So what I do is I put together this diagram. It's basically start with the interview prep, ask me a couple of questions, and then perform an analysis of how I did, right? So what I do is I copy this, go to this chat window, paste it here, and say, help me develop an application following the above high-level flow. and it basically can understand what I'm telling it to do it. It's understanding what this diagram looks like. It's saying the flow is clear and an interview prepare app. Uh, if you notice, I didn't provide any context. Everything is in there in the image. So it is able to read that. It is identifying there are 4 steps, and then it is asking me follow-up questions. Do you want to use a real AI LLM for the analysis? How many questions? Any specific interview type? So I'll respond with yes, use AI, or actually I will no, just keep the analysis simple, keep it to 3 questions, and keep questions generic. I'll say use spec-driven. So it is saying, okay, this the question I have asked is perfect for spec-driven development. So it's asking, would you like to start a dedicated spec session? I click yes, and now it is working behind the scene to figure out what specification that it has to come up for this particular project. So what it is doing is it is actually generating a specification. It is understanding what all requirements needs to be there for this particular project to build. It is going to define the detailed documentation of this particular image that I have put together. So let's give it a few seconds while it is working. And you will see on the left-hand side, it will start adding some of these. It will start adding some of these configurations under the specs. So you can see here, it is writing the requirements.md file. What this file is essentially going to have is it will contain all the requirements based on the diagram that I've provided, and it is a simple .md file. So it's not that I don't have control over what requirements this is going to be. It's just a good starting point for me with a high-level flow. However, it is going to come back and show me what these requirements look like. So you can see here, it has provided a detailed introduction, what this app looks like. It also came up with the glossary. It has the requirements. You can see there's a start screen. Requirements 2 has question presentation. It also provides the acceptance criteria for each requirement. So it is coming up with what are these acceptances going to be once it has implemented that feature. Now, I have full control over these requirements. If I will go through it, and if I don't like something or if I want to change something, I can actually go ahead and change it. Now, just for the purpose of demo, I will say, okay, everything looks good, and I'll say continue. Now, the next step is generating the design. So it's going to look into all these requirements, and it is going to come up with the design document. The design document is going to contain a very high-level design for each of these requirements. It will also create interfaces that needs to be implemented. It will identify what are the inputs, what are the outputs that is going to be, and all of that is going to be put in a design.md file. So let's give it a couple of seconds probably to generate these design. And you will notice that I already have the requirements file on the left, and now it is started to put the design doc. Now, if I click the design here, you see it has already came up with the architecture. This architecture is based on, if you remember earlier, I have this the white framework that I'm using. So it went through my workspace. It understood what is the libraries and what is the framework that I'm actually using it. And it is coming up with an architecture based on that specific workspace files that I have. So it's using all the learnings that I have put it there to be able to come up with the design for this particular application. Now you see it has some of the design decisions. So it has made some design decisions based on the requirements that it has came up with. I can go and change these design decisions if I want. I can change these components and interfaces. When I am writing an application, I like to actually have all of these specifications up front so that I know exactly what are going to be the inputs, what are going to be the outputs, what are the interfaces that it's going to implement, and then what are the data models that are going to have. It also put a few sample questions. So if I don't like some of these, I can go ahead and change it. So let's say I put, tell me about yourself, describe a challenge you faced, and then where do you see yourself in 5 years? Okay, I want to change, let's say, 3 years, right? Who knows what happens in 5 years in this age, right? So yeah, 5 years too long. Let's put 3 years, or maybe a year. Things are changing so fast. Yeah, in a year, right? Where do you see yourself? Maybe we don't exist in a year. Everything is done automatically. Okay, so it seems good. Design looks good to me. Now I probably want to move to the next. So after I have a design and requirement, now I want to define exact tasks that needs to be implemented to actually build this application. So I say continue here and generate tasks. So what it is doing, you'll see, let's go back to our spec, and it's going through the design, it's going through the requirements, and now it is going to generate these tasks for each of these design decisions and the requirements. You will also notice that this is very similar to if you are used to the software development lifecycle. These are user stories. Generally, in a product management, generally the product managers work with the engineers to come up with these user stories, and then these user stories are going to be assigned to different engineers within the team. This is exactly what it is doing. It is going through the design and the requirements and coming up with these user stories or tasks in this, in the world of Kiro, we call it tasks. And it's creating this tasks.md file that you see. And it's going to map each user story or each task back to the requirements. So you can see exactly what requirement is there and how it is mapped to different tasks. So you will see there are, for example, it came up with these tasks. There are, I don't know, around 10 different tasks. Some are optional and some are mandatory. Now, the way it is defining optional and mandatory tasks are like unit tests and documentation. It is keeping it optional for, let's say, if I want to just build this project for my local, I'm not pushing it into production, I just want to do a quick prototype, I can keep these optional tasks optional and not implement it for my local. But if I'm doing it in production, I would likely need to have all of those things implemented. And you see, for each task, it is mapping back to the requirements. So you can see these tasks, if I implement or agent implements this, these are the requirements that are going to be fulfilled. So you have a clear map of which requirements are going to be implemented by which tasks. Again, this is a simple MD file. I can go and make changes, and if I'm happy with it, I can go and say, okay, go ahead and run it, which means go ahead and implement all these tasks. Now it is asking, do you want to run required tasks or do you want to run required and optional tasks both? Like I said, optionals are, for example, writing unit test. For now, I'll just, for the time being, I'll say run required tasks. And this is going to have, go over all these tasks. It will use this, it will queue all these tasks. So you can see the status of these tasks have changed from start tasks to task queued, which means Kiro has started to look into these tasks. It has identifying which task needs to be implemented first, which task needs to be implemented later based on the dependency, and it has queued all these tasks. Now it's going to take at least 10 to 15 minutes before it can actually implement all of that, but I would like to quickly show what does it look like when it is done. So if you see here, I have already finished this just for the demo purposes. When it is implementing these tasks, it is actually making a note of these things. It is marking the task complete and moving on, and it is checking every task that it is completing. So you can see it is making a note of which task has been completed and which are not. And once it is done, it's going to automatically start your this application as well. So let's say, how does it look like? And there you go, right? This is the application that it has. I can say, okay, let's test this. So I'll say start interview prep. It's asking, tell me about yourself. I'm Shivansh Singh. I'm a principal solution architect at AWS. Next question. My greatest strength is to use Kiro and write applications end to end. Why not? What accomplishments are you most proud of? Being able to write code in front of hundreds of audience and a live demo, right? Okay, so did really bad because I didn't do well providing detailed answers. But this is it is able to put together in like 15 minutes of going all the way from requirements, or not even requirements, providing a flow diagram of how I imagine an app should work, coming up with the requirements, coming up with the design, identifying the tasks, and then implementing it. So I followed the same exact software development lifecycle that usually takes weeks, or if not months, and being able to use Kiro, the agentic AI development IDE, to implement this application end to end. Now, this is a sample app, but this gives you an understanding of how this can actually expedite and help engineers to write products and build products end to end using the same learnings that we have over the decade for software development lifecycle. So that's what the spec-driven development looks like. Now, I have already gone through this, so I'm not going to go over this again. I already did this. One of the things that I want to mention here is, if I go, let's say here, as you are developing and the application using Kiro, it automatically, a lot of times you'll see that you have already moved to a certain, you have made certain progress, but then you saw something wrong and you want to roll back. But a lot of times it happens that you are just too busy talking to it or chatting with it, and you have gone too far ahead without, let's say, committing your code or making those things persistent. So there is, it automatically keeps checkpoint within the IDE. I show it here. Okay, maybe I have not done it here enough, but in here, if you see, it's in the IDE, it keeps, there's a thing called restore, and if I click that restore, everything that I have done past it, it is automatically going to be restored to that checkpoint. So I'm not going to lose any of the progress, even if I have not done it in the Git commit. So it's kind of keeping the history and all of that implementation. So Kiro is also available in terminal. So if some of you like to use terminal, like some of the other agentic IDEs, you can use terminal as well. And then you can build custom agents using Kiro as well. We don't have enough time to go over it, but one of the capabilities that you can build custom agents. These are some of the pricing tiers, so you can get started with Kiro for free. You can just need an email address or a GitHub account, or you can create a builder ID. You can get started for free, and then there are different tiers of Kiro from $20 per month as a pro tier, with $40 per month for Pro Plus, and $200 for Power tier. That's all for today. Thank you. Yeah.
Or just how Sorry. So I'm saying just when you run the tasks, if one of the tasks in the middle throw an error, so what happens? So it stops there or just continues to running the other tasks?
Yeah, so it automatically knows the dependency. So if there is a task that fails and there is a dependent task that requires that task to be completed, it will pause that dependent tasks, and then when you do the sync file, it automatically updates all of it, goes through the code what it has implemented, and it updates the status of each of those tasks. So it will identify which task has failed, and it will automatically try to restart that task implementation based on what it failed and why it failed. And it will move on to the next task once that task has been completed. So it is able to identify on its own which task has failed and why, and improve it for the next time.
So it does that itself. So
Correct.
it's not just human.
Exactly. Yeah.
That's nice. Thank you.
Shivansh, thank you. This is great. One quick question. If I wanted to use another app, like this is a good example use case. Let's say if I wanted to make it voice activated, use Alex. If I wanted to add that in, how would I do that in this scenario? You know, it's giving me text now. And let's say if I wanted to use Alexa.
Yeah. So I when you are starting with the, let's say it's part of your requirement, right? One of your requirement is that it needs to use Lex or voice chat, and you should be able to use Lex, for example, to be able to convert your voice into the text. You can provide it as part of the requirement when you are actually interacting with Kiro. So when it comes up with, there are two ways actually you can do. Either in the first prompt itself, you tell it that I want to use these services. If you have an architecture in mind or a specific implementation, you can provide upfront. Or when it has generated the requirement, before you go to the design, you actually add that as part of the requirement in the requirements.md file. And that way, when actually it is going to the design phase, it is going to consider that requirement to come up with a design which includes that particular Lex requirement that you have to implement it. So you can do it either directly in the requirements.md file, or you can just chat it and say, I want to use Lex for voice interaction, and this is one of the requirements. So it will automatically take that input and add it in the requirement file.
And if you don't have Lex, let's say you don't have the application, you're not paying for it, would it add it in and then say, okay, you got to pay? How does it interact with the service?
So you don't want to use Lex, you said, or?
Well, let's say if I wanted to use it, I don't have it implemented yet. I don't have it. I don't have a service. I'm not paying for it yet.
Uh-huh.
How would Kiro use it? Would it bring it up and then ask you, or
yeah, so
use it and say,
if
okay,
you provide it, yeah, so you can actually provide access. If you have AWS credentials configured in your local, it can use those credentials to check in your AWS account whether you have that specific thing running in your application or not. If not, it is able to tell you that, hey, this is not running. Would you like me to go and create, or you want to do something else? And based on your input, it can actually go and create it, or it can provide you some alternative options that if you want to use something else, let's say a local LLM for converting, or a local library or a web tool to convert those voice into text.
Excellent, thank you.
The follow-up question I have is, if I change the design or requirements, does it regenerate all the files again, or is it only certain parts of it? The reason I ask is we've got very big projects right now, right? And we run test cases, we get such big MD files, and it's like, every time I have to give data to it and it regenerates the whole file, it becomes like a lot of money wasted and a lot of learning that's not been captured in the MD file. Again, you have to go through the same loops again and again and again, because, okay, so as an example, we had a failure last time. We said, okay, let's put this learning into a file, let's move forward. Yeah. We put it into an MD file and we go ahead, it builds something, changes something, but it misses something else, right? And so we have all these cases. How do you track that?
Yeah, so great question, because this comes down to what should be the scope of a spec, right? Do you have a spec at the entire organization level, you have a spec at a project level, or you have a spec at a much more granular level. My personal recommendation is don't create a spec at a large project level. Don't make a spec as a living document. Keep spec as a smaller unit such that once it is implemented, it is done. You don't go back to that spec again. If you want to do a bug fix, like for example, you identified an issue, you want to do a fix, you actually do it through a new spec, or there is you might have not noticed, but when I actually give it a prompt, it asks me, do you want to start with a design or is it a bug fix? And it automatically identifies that it's a bug fix based on the prompt I give, or it is a brand new feature. So if it's a bug fix, like for example, in your case, you identified an issue and you want to fix it, you will say it's a bug fix. So it's going to generate a new spec for that specific feature and the bug fix itself. And it is going to create, if there's a design change, it will automatically identify what the design change is, and it will only generate the tasks for that specific bug fix only. So treat these specs as a throwable documents. It's not a living document that you keep it forever for your entire project, because being able to change the requirement, like you said, for any small thing, you go back and change the requirement, change all the design, change all the tasks. It's just not useful. So scoping the spec is a very important piece. I think I already ran over time, so thank you so much, everyone.
Can I ask a quick question? Here?
Sure.
Yeah, I'm a teacher. I teach adult ed, IT, and AP computer science at the high school level. Having this skill, will this give junior engineers an edge to get in? Because a lot of college students who graduate with a CS major are having a hard trouble getting a job in CS. Is this AI tool going to help them get a foot in the door?
Yeah.
Or will they be hireable? Because I mean, do companies want people with this skill set?
100%. I think all the time, like having an AI skill or being able to use these tools, AI tools, and how to know when to use and what to use in a best practice way is going to be critical now getting into the market. And absolutely, you still need the fundamentals, how these things work, how underneath, because once it is done, yes, you can use these tools to debug, to find issues and troubleshoot, but still be able to understand what exactly it is doing, how it is doing, and being able to troubleshoot. So you still need those foundations, but knowing this skill almost becomes requirement now to be able to get into the market, in my opinion. Thank you.
I actually had a last question for you.
Yeah.
So how do you change the acceptance criteria for the requirements? If you can repeat one more time.
So you can actually go back here and you can change whatever you want in each of these requirements. So, oh. Yeah, so you go back to the requirements file, and for whatever requirements you want to change the acceptance criteria, you actually go and change the acceptance criteria. Yeah, this is just a plain .md file. So I can say, oh, the result must display the numeric score out of 10. And I can just save it, and it will continue to automatically update. I can say continue, and then it will change the design based on what I have changed in the requirement.